Hello and welcome back to day 10 of Advent of Code 2023. We are in the double digits, which is officially the furthest I've ever made it. Actually, I think I've mostly given up around day 5 or 6 or something like that. So it's cool. We've come far. I realized I need to learn a lot about Clojure still. There's so many functions that I just don't use or don't have in my head, and there's a fantastic channel in the Clojurians Slack about Advent of Code, and people have like the craziest solutions. Makes me feel real dumb. But that's how it is. Let me quickly adjust this a little bit. Yes, isn't that lovely? Okay, day 10, Pipe Maze. You use the hang glider to ride the hot air from Desert Island all the way up to Floating Metal Island. This island is surprisingly cold and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs pointing in a seemingly consistent direction. Well, that's good at least. Maybe you can find someone at the hot springs and can ask them where the desert machine parts are made. The landscape here is alien, even the flowers and trees are made of metal. It reminds me of the SpongeBob episode where everything is chrome and Thaddeus goes like, the future. So anyway, as you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. You make a quick sketch of all the surface pipes. You can see your puzzle input. The pipes are arranged in a two-dimensional grid of tiles. A vertical pipe, horizontal pipe, 90-degree bend, connecting north and east, 90-degree between north and west, south and west, and south and east. Dot is ground, there is no pipe in this tile. S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Based on the acoustics of the animal scurrying, you're confident the pipe that contains the animal is one large continuous loop. For example, here's a square loop of a pipe. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. Okay. In the above diagram, the S-tile is still a 90-degree F-bend. You can tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same as above. In the above diagram, you can still figure out which pipe form the main loop. They're the ones connected to S-pipe. Those pipes connect to pipes to S pipes, those pipes connect to pipes, those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to those two pipes. My brain, the word pipes has lost all meanings. Here is a sketch that contains a slightly more complex main loop. So this goes like this. And then here's shown example sketch with the extra non-main loop pipe tiles also shown. Okay. You should find the tile in the loop that is the farthest from the starting position because the animal is in the pipe. It doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. In the first example with the square loop, you can count the distance each tile loop from the starting point. 0, 1, 2, 3, 4. 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Boah, find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? Oh, this is horrible. It's all the things I don't like. Okay. I'm gonna quickly prep the input in the first test. Alrighty, so let's do this. So what I'm thinking is if we can parse this somehow in X and Y and then which one it is. So like north, north, east or something like that. Not sure. East, west, right? Like effectively we have the 1, 2, 3, 4, 5, 6. We can just ignore ground. And then I feel like we can just ignore everything that's ground and just not add it to our map. Actually, if we just do a split lines, then they're already. So if we have something like string / split lines, A, B, C, \n 1, 2, 3. Can't we do a? I always forget if you can get like a get in here as whoa. 1, 1. Does it work? That is 2. Nice. So that does work. So maybe all we do is we split it into the lines, find the S, and then just go along. And what we have to do is we have to somehow figure out when we get back closer again. So if you would just go round and you would go. If you would just go round, you would count 1, 2, 3, 4, 5, 6, 7 back at 8, and that's just half of it, right? So you could just go round until you're back at S and then divide by 2. Right? I think so. Doesn't matter the shape, does it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 divided by 2. Okay, we're just gonna try that. Maybe there's something wrong with my way of thinking here, but I think that should work. So what I want to find is I want to find I want to do let lines or yeah, whatever lines, string / split lines, raw pipes. And I want to find the starting position, and that is what is string / index of character sequence value. So if we have A, B, C, and we say B, it should give us B. It should give us 1. And if we say D, it should give us, I guess, nil. Okay, that's cool. So if we say first, first where Fn I want to map over the index, basically. I want to do a mapped index and find the first one line and then return this like string / index of line S. Oh, and I want to return what's it complaining about? Expected sequence or collection. Oh, map indexed. There we are. That's what I wanted. And it's still a bit of a brain fart. That's okay. And I did something wrong here, didn't I? Where are we? Here, map indexed. In the map indexed here, lines. And then I want to just like return start for now. Still complaining. It's called with 2 arcs, but expected. Oh, are they? They're not. It's called like this, isn't it? Yeah. Okay. So what do we get back? 0, 0. No. Ah. What was it? I just want, because filter is returns a lazy item for which predicate item returns a logically true value. Yeah, that's not what I want. Isn't there like, I'm thinking of something else. There's a new, struggling here. Remove keep. Returns a lazy sequence of non-nil results. Okay, I don't know. Maybe I'm just dumb. If second x, not x, percent. What's its problem now? Oh. Up. Miss. Bup. first, right? One, one. Is that right? 1, 1. Yeah, okay. That sounds right. Okay, so this is our starting point. And now we need to find which pipe connects to S. And how do we know if it connects to S? If it is... yeah, okay. I think like once we have the pipe, the first pipe that connects to S, then we just follow them. Because we know which way we're like facing. So we move that direction and we know which way this turns us, and then we just go basically that way. So we can like, as soon as we have this one, we know this one is, we went east. So we're facing east, which means we're going to move one over here, and now we know this one is going to turn us south, so we move one south. We know on that one, if you're facing south, you keep going south, so you go over here, and then we know this one is going to turn us west, so we move over here. Okay, I feel like we just need to find the first just need to find the first one, really. So find connection to start. So we have the start X and Y. So our candidates are B, decrement. Should I just type it out? Probably. Oh, actually, I want to try something. Which one is, not that I have it the wrong way around now. One, two. So yeah, that is Y and this is X. Or line and yeah, let's just call them line index line. So what we end up with is start, and the start would then be line index and character index. And we need all the lines. And we probably want to uncomment all of this here. So we decrement the line index, we decrement the character index, we brain already hurts. So we decrement the line index, we do nothing to the character index, we decrement the line index, we increment the character index. So number one, then okay, this is part of the let. Next ones, we basically want we do nothing to the line index. We decrement and increment the character index. Lovely. And then inc paste. So instead of decrementing, we increment, increment, increment. Those are 8 neighbors, right? So we then map fn line index character index. We do a get in lines get in lines. Oh, can I just do index here? And then say, would be interesting. So if I just do a print line, find connection to start with start and lines. Candidates, right? We want to map over candidates. So no I in this context. Yeah, that's correct. Okay, so run this and it explodes. Horribly explodes. Integer cannot be cast to function. Nine. Oh, yeah. That makes sense, doesn't it? So our connection points are, well, let's fix this again. Our connections are a bunch of dots, a pipe this way, and a pipe that way. Yeah, okay. And then what we probably need to keep is the index as well, right? Yeah, okay. Then what we can do is we can filter everything that's not ground. Why is it important? Probably isn't important. Okay. What we need to figure out now is basically if something is connected to our starting one. So it is... Oh, actually, no, there are no diagonal connections. This was dumb. This was very dumb. It can only connect on these 4 points. So let's get rid of thinking Jacob. This one. Oh, oops. So don't need this one, don't need that one, do need this one, do need that one, don't need this one. So these are actually the only 4 that can have a connection. Okay. I'm thinking, should we be more explicit? Def n is connected. So case north of it it is connected north of it if it is this or 7 or what's the other one? An F. Then if it is south, they are connected if it is another one of these, or a J, or a L. Of pipe. East, when it is either this one or that one, right? Like a J going up or a 7 going down. And west, if it is either, again, one of the horizontal pipes or an L going up or an F going down. And then we change this to say this is this the north one. And then we immediately switch it out to pipe. And we just do the get in immediately. Get in lines this. And we're gonna do that for direction north pipe this. So the one where we are on the same one, that is the west pipe, where we decrement the character index. This is the east pipe. Oops. And then this is the south one. And that's where we increment the character index. So south. So map connected candidates. And print line candidates. And then change this to be a keys. So. So this one is connected and that one is connected. Lovely. We should probably change this to like when that then candidate as candidate. When I don't know, is there a better way of doing this? It feels all very, very repetitive. I guess what we could do is we could say let connections so if we just do north south east west like this, and then we just do when direction in connections over pipe. Oh, what did I do? So we can get rid of this. Then candidate. So null direction east pipe and direction south pipe, and we just grab the first one. Actually, should I just do a filter connected, huh? And then a first. Direction east pipe, amazing. And with this, we also know which way we're facing. So start, then first connection is find connection to start. So and now we need just a function that takes every symbol and which way we're facing and the current index and which one's the next index. So next index. Or like next step maybe. So it takes lines and then it needs to take the index, the direction, and the pipe. And what we need to return is the next index, the next direction. I feel like we need to pack this all up in a And a nice simple map keys. So. If let next pipe be something, our next step, and then we say if pipe of next step is S, then we're finished and we return the count. So first connection. Actually AoC first connection index. Oh no. Why do we not have? The index isn't on here. Ha! That's sad. That is very ugly, isn't it? Okay. Map fn candidate AoC candidate pipe get in lines index candidate So what do our candidates look like now? I want to ignore this. Nil. Yeah, well, that's not good. Okay. Ah. Hmm. Ah. Bad. That's why. So, okay. That's better now, isn't it? And the first one that is connected is now what we return. So if we run this, the first connection is direction east, index 1, 2. That is it, right? 1, 2, 0, 1, 2. Yeah, perfect. And the pipe is this pipe. So back to our loop. We count 1, and the next step is our connection to start. Oh, actually, I guess we can just inline this here, right? So loop if, well, next step will be calculated. If the pipe in next step is an S, return the count, else recur, increment the count. And now we need to find the next step. find next over, should this be called next step or should it just be called step position? Position. Find next position. That. So find next position lines. Index direction pipe. So line fn, index fn. So if the pipe so I'm thinking we need like a def next positions, something like that. So if the current, what is more important, the pipe or the direction? I think the pipe, right? So we have a pipe like this and the direction is east, then we need to return. The line stays the same. That one will be incremented and the direction is still east. If we face west, then the identity stays the same. The line stays the same. We will move one to the one and we are west. If we are on this pipe, we can only go north and south. So if we're currently facing south, then we increment that one, keep that one the same, and we still face south. If we are going north, then we decrement the line, we keep identity, we stay in the same character lane, and we still go north. So if I hope this works the way I want it to. There are 1, 2, 3, 4, 5, 6, right? There's a J, an F, a L, and a 7. So a J goes, oh, it's honestly hurting my brain, north and west. So if we currently are facing south, then we're gonna end up west. So we need to, well, it's the other way around for you, but we need to decrement that one, and we head west. If we're coming from facing east, then we need to, oh wait, actually no, we go, we increment that one. So we decrement that one. We decrement that one, and now we're facing north. What was F again? South and east. So if we are facing north, we're gonna end up facing east. Well, that's easy at least, I think. So we need to decrement the line to walk up and increment the character to go to the right. We need, when we're facing west, we need to increment the line to go down, decrement, and then we're facing south. So this, that is a decrement. It's an increment, decrement. So did I get these wrong here? So if we're facing south, you need to increment the line, decrement the character. If you're coming here, you need to decrement the line, increment the character. Ooh. Right, this way. I hope. I don't know if I'm getting anything wrong. I'm gonna try typing them all out. My brain. L. So if we're facing south, we need to increment the line, increment the character, and now we're facing east. If we're facing west, we need to decrement, decrement, and now we're facing north. 7. What's this connection, right? So if we're facing east, we will increment the line, increment the character, and now we're facing south. And if we're facing north, we will decrement, decrement, west. Next positions. Pipe direction. Update. Okay, in. Update. So, AoC I think. I don't know. Boy, hurts my brain. Okay. I don't know. Might be it. Might not be it. There's only one way to find out. Immediately explodes. Line Fn is null. Okay, so I did an underscore here. Okay, so it went here, down, and then over. It went facing east. That stays the same, doesn't it? So 1, 2. This one. We went over to 1, 3. We went down to 2, 3. We went down to 3, 3. We now need to go to 3, 2. So on a J, when you're facing south, that stays the same. Is that the same then here? When you're facing east, you just need to go up? Probably. So then we hit the L. We're facing north. No, we're facing west on the north, on that one. So that decrements, but that is identity. It's always opposite, isn't it? I think. I don't know. So, and now we're back at S. And we return the count. Is it 8? Yeah, it is 8. Lovely. So loop that divide by 2. Yay, okay. Let's grab that one. Should be 8 on this one. Def test returns 8 for second example. So cannot invoke object with line function is null. Okay. What is... Oh no, I removed the... That was so useful. So we found... Hold on. connection to start 2-2. That should be 2-1, shouldn't it? The J, no, 2-1, all good. So we're facing east onto 2-1. Onto that one. So we need to land on decrement identity. Yeah, it's always, and then the same across, and then the F I haven't gotten yet, but we'll get to the F. Right, that's now. So if we face the F, hold on, east into a J. Facing north. Facing north, the index is 1-1. We need to turn right, so to the east. This is gonna stay the same. Okay. Alright, I'm gonna grab the input and see if it works. Okay, let's try it. I'm sure we're gonna get lost, right? Find farthest step. Oh. Hey! Nice! Boy, I mean, it took long. I've been at it for an hour now. But it was kind of fun, to be honest. So let's see part 2. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. You determine whether it's even worth taking the time to search for such a nest. You should calculate how many tiles are contained within. No. No. Yeah, no. I'm gonna leave it here. For now, I might come back and do a separate video on part 2. Because that seems like a huge problem. Or maybe I'm just dumb. I don't know. But yeah, thank you very much for watching part 1. I hope to see you next time. Bye bye.